Chapter 12: Impact of Extraterrestrial Objects. One of the biggest meteorite impact on Earth is the Sudbury meteorite impact. The Sudbury Igneous Complex of Ontario, Canada is the remnant of a voluminous melt sheet produced in a few minutes by impact of a massive meteorite into continental crust. This is 1.85 billion years ago. It's one of the biggest impact craters on the Earth. Even if you go there today, you can see some of the relics, some of the features, some leftovers after this meteorite impact. So number of research were developed after Sudbury meteorite impact. The Earth's place in space. So why Earth is unique and why Earth is important. So this is the only planet in the solar system is believed to host life, and also the planet filled with and modified by life, and also periodic drama caused by continued impact of material from outer space such as asteroids, meteorites, and comets. Meteorites and asteroids from the asteroid belt between the orbits of Mars and Jupiter, whereas comets from Kuiper belt. So here is the picture of the solar system where you can see the terrestrial planets. Those are rocky and solid planets based upon the nebula hypothesis. We are talking about denser and heavier particles concentrate towards the center of the solar nebula, and the sun is ignited. Actually at the beginning is the proto-sun was ignited, and the other planets orbits around the sun. And Mercury, Venus, Earth, and Mars are considered as the terrestrial planets, and Jupiter, Saturn, Uranus, Neptune considered as the Jovian planets. The Jovian planets are more gaseous planets. The asteroid belt is in between these two different planets. Earth is unique. Why? So Earth is unique for a couple of different reasons. Earth's gravitational force, having atmosphere, and water in liquid form where plants and animals can use, and plate tectonics. Not any other planet showing plate tectonics. So these are major reasons why our Earth is very unique compared to rest of the planets in our solar system. Asteroids. The size of the asteroid is changing from 10 meters to 1000 kilometers, and composed of rocky or metallic material or rock metal mixtures, most of them in asteroid belt between Mars and Jupiter. Some of their orbits and entering Earth orbit due to collision of asteroids. Meteorites. Small fragmented space particles from disintegration of asteroids are called the meteorites. Size is ranging from dust size to few meters. Meteor is the burning meteorites due to frictional heat from their entrance to Earth's atmosphere. Meteor shower is a large number of meteors come to the Earth's surface at the same time. Comets. Comets, they are originated from the Kuiper belt deep in the solar system. Between it's about 50,000 times the distance between Earth and the Sun. The size ranging from few meters to few hundred kilometers. Compositionally, this is a rocky core and surrounded by ice and covered by carbon-rich dust. Orbit, that intersects Earth's orbit sometimes. This is once again the solar system where you can understand the terrestrial planets towards the center, Jovian planets away from the sun, and asteroid belt in between terrestrial versus Jovian planets, and Kuiper belt is surrounding the all of these solar system. Early evolution of Earth. The bombarded by meteorites, asteroids, or comets. So this is known as MACs. The formation and makeup of Earth contributed by the impact of the MACs in other words, meteorites, asteroids, or comets. Earth's evolution greatly affected by the impacts, both destruction and construction effects. MAC is traveling at high speed, 26,000 to 156,000 miles per hour. You can imagine the speed compared to your driving speed. Undergo remarkable changes when entering Earth's atmosphere, aerial burst or collide with Earth. Aerial burst as the meteorite entered in the atmosphere at about 85 kilometers above Earth's surface became a meteor that emits light and disintegrated in the air. So that's basically burning. Cause direct impacts on collision with Earth. So aerial burst and impact, so you can see what I just mentioned. So this is a meteorite and it become meteor, and air burst and meteorite. So these three words actually very similar, but you can see the difference. So the meteoroid, meteor, and meteorite when it's on the Earth's surface, like Sudbury meteorite. Impact craters. The most direct and obvious evidence of extraterrestrial impacts are impact craters. That's what we've been talking about. So 50,000 years old Beringer crater in Arizona is one of the examples, the most famous meteor crater in the United States. This is 1.2 kilometers in diameter and 590 feet in depth, ball-shaped depression with upraised ejection rim. This resulted from the impact of a small asteroid 25 to 100 meter in diameter. So you can imagine the impact. So this is a picture, the Beringer crater in Arizona. Craters involved with extremely high temperature, velocity, and pressure, different from craters from other terrestrial geological processes. Shocking metamorphism is one of the result coming after this meteoritic impact. That's forming high pressure modified minerals such as quartz or materials of mixing partial melting rocks and impacting objects. So other associated processes, vaporization, melting, and ejection of materials you can expect to see when you're developing these craters after the meteoritic impact. So this is one of the evidence for shock metamorphism, or it's also known as impact metamorphism. It's high pressure, high temperature condition, and rocks deform. The existing rocks get deformed and forming metamorphic rocks. So shatter cones is one of the structural change that you can expect to see right after meteorite impact. So this is very common feature that you can see in Sudbury meteoritic impact in Canada. Massive extinction or mass extinction. This is very famous word or the phrase in geology. So massive and sudden loss of plants and animals relative to the number of new species being added is known as the mass extinction. Several hypotheses suggested that rapid climate change, plate tectonics, extremely large volcanic events, and the impacts of extraterrestrial objects can cause the massive extinction or mass extinction. There are six major mass extinctions during the last 540 million years. So end of Ordovician, Devonian, Permian, Cretaceous, Eocene, and near the end of Pleistocene. It's nearly 2 million years to present. That's the time period. So these six major mass extinctions were caused by different reasons. Still, they are hypotheses, but remember, hypothesis is an educated guess based on the evidences, based on the observations. Earliest, nearly 4.43 million years, near end of Ordovician period, extinction of 100 families and associated species related to global cooling. The second is 350 million years, near the end of Devonian, death of 70% of all marine invertebrates, probably related to climate change and global cooling. Third is 245 million years ago, the end of Permian, 95% of all marine species, possibly caused by more than a single catastrophe, likely spanned for a 7 million year period. The fourth, around KT boundary, Cretaceous Tertiary boundary 65 million years ago, abundant evidence to suggest that it was caused by an impact of giant asteroid diameter of 10 kilometers in the vicinity of the Yucatan Peninsula. Extinction: about 70% of all genera such as dominant species of dinosaurs. The KD boundary was a very thin layer of clay. Fossils found in rocks below the clay were not in rocks above the clay. Setting stage for the evolution of mammals, including humans. That was a very massive mass extinction among these six extinctions. The fifth mass extinction near the end of Eocene, 35 million years ago, likely resulted from cooling and glaciation. And sixth, the near end of Pleistocene to present, is ongoing mass extinction of mammals, reptiles, amphibians, birds, fish, and plants. Overhunting by Stone Age men may have been a partial cause of this event. Extraterrestrial impact 12,900 years ago. What is that? The North America was ecologically different 13,000 years ago, populated by Pleistocene megafauna that included mammoths, direwolves, American lions, short-faced bears, giant ground sloths, camels, and horses. Paleo-Americans, especially the Clovis culture. The possible causes of the extinction of the megafauna and the termination of Clovis culture is extraterrestrial cosmic impact 12,900 years ago. More physical evidence related to the possible impact to be discovered. 65 million years ago, a comet or asteroid with a diameter of about 10 kilometers impacted Earth in the vicinity of what is now the Yucatan Peninsula. Concentration of a platinum metal called iridium in the thin clay layer that represented the KD boundary in Italy. Many fossils found in rocks below the clay were not in rocks above the clay layer. So this is a very interesting and very good observation. A buried impact crater with a diameter of approximately 180 kilometers at the Yucatan Peninsula is discovered in 1991, not too far. Impact triggered global fire. The vaporization of the limestone bedrock, which contains some sulfur, produced sulfuric acid in the atmosphere. Additional acids were added as a result of burning nitrogen in the atmosphere. Following the impact, a long period of acidic rainfall, the dust in the atmosphere circled Earth. There was essentially no sunlight reaching the lower atmosphere. The food chain virtually stopped functioning because photosynthesis stopped as a result of covering the sun rays towards the Earth. So here's the KD boundary mass extinction in pictures. So you can see the impact, the fireball and shock waves and changing the rocks, changing the minerals and changing the atmosphere, and the vaporization of water and nitrogen into the atmosphere that covers the sunlight, and the acid rains and sunlight blocked little or no photosynthesis. So that's impact winter because albedo changes, and that is something we'll be talking about later. So the sunlight has to return, and erosion and deposition is modified crater. So this is the hypothesis, and that's a very good educated guess based on the observations and evidences that we have today. So environmental risk of the impact. This is what we need to talk about in this class. So depending upon both the probabilities and the consequences of the impacts, and catastrophic impact risk is aerial blast or direct ground impact. So the impact area, regional or global scale, or max extinction. So these things needs to be clear. Smaller event about every 1,000 years, and larger event occur every 40 to 100 million years or so. So these are happening, and there's no way that we can go catch these and prevent this. This is happening, but we need to know what we can do about this. So this is showing you the asteroid or comet diameter in the top x-axis, and the bottom x-axis is showing the explosive power in billions of tons of TNT. And the Chicxulub is a Yucatan Plateau. That's it, the Chicxulub meteoritic impact 65 million years ago. This is what we talked about, the KT boundary impact, and this is the 35 million years ago, and the Beringer meteoritic impact is right here, so Tunguska right here. So likewise, you can see where these different impacts locate on this chart. Y-axis is telling the typical interval between events. So 10 years, 100 years, 1,000 years, million years, likewise. Minimizing the impact hazard. So identify all potential hazardous near-Earth objects, NEOs, near-Earth objects. This is why we have to have a good knowledge about astrology, and also astronomy and geophysics. So this needs to be understand clearly, and with the development in the technology, like finding the Hubble telescope is one of the key points that you're talking about. Different galaxies, different solar system, different planets. So that kind of encourage us to learn more about these planetary objects and how they are functioning, and all the processes or the mechanisms. They categorize the comets and asteroids crossing Earth's orbits. A Space Watch program developed in 1981 about to expand its observation to the entire solar system. NEAT, that means Near Earth Asteroid Tracking System, supported by NASA, focusing on the size and distribution of near Earth objects. Around 135,000 Earth crossing asteroids with a diameter of 100 meter or less. About 20 million near Earth objects, 4% with the ability to penetrate and excavate a crater, another 40% to penetrate the atmosphere and pose a threat. Designing an approach to divert large objects away, and designing a plan for early evacuation for smaller impact events if precise location can be predicted. So this is where we are. So these are some important points that you can think of for your critical thinking topics. And I think this is very interesting. So unlike the other hazards that we discuss in the class, this is kind of very natural, and everything else is natural as well, but this is something very massive and causing to large number of species, large number of genera. So this is like a global impact compared to other natural hazards. Like if you think about landslides, that's local. River or flooding, that's kind of local. Coastal erosion, that's more local. But this is global impact. So we need to consider about this. And I hope you enjoy this little slides. And that's the end of the chapter 12.